Alright, finally we've made it to our review on statistics. So let's make sure that we know what's going on here. My suggestion for this would be to treat this as the test. Try to do it at home. Try to work out every single problem. Go through the whole thing. Do anything and everything you can. Then to watch this video, and then you can check to see how well you did. And you can find your mistakes, and you should be able to do a lot better. Okay? So please do that. Anyway, let's get going with this. So, it says our Q scores are normally distributed with a mean score of 100 and a standard deviation of 15. Right? So we've got our mean of 100 and our standard deviation of 15. It says draw the normal distribution for IQ scores. Okay? So, we would take a look at this and draw it out as our bell curve. Okay, and it looks like we have some marks on here. So we'll call that our mean. I didn't draw that very good, did I? Let's try that again. That'll work. Not the best. Okay, so that would be at 100 would be our mean. Okay. And then if we went one standard deviation away, okay, we would add 15 and subtract 15, right? So that would be 115. To the left would be 85. Then we add our two standard deviations away. That would be 130. That would be 70. And three standard deviations away, 145. And 55. Okay, so that's what our bell curve would look like, the distribution. Okay, so yeah. Alright, so what percent of scores are within two standard deviations of the mean? So remember, one standard deviation, 68%. So that would be 34 and 34. Okay, two standard deviations away. That's what we're answering here. That would be 95%. Okay, so that would be the answer to number 2. Okay, and that's 13.5% and 13.5%. Then three standard deviations away. That's the 99.7%. Those are numbers you need to remember. This would be 2.35% and 0.15, 2.35% and 1.15. Okay. If we were to split them up individually per intervals. So what percent of scores are less than 70? Okay. So because 70 is one of our deviations, okay, we can use that. Okay, that's why it's a good idea to know those separate ones, right? Each one of these. So we want to know what's below here. So we would just add those up. So it would be 0.15 and 2.35. 0.15 and 2.35. So we add those up. Okay. Be 2.5. So 2.5% are less than 70. What percent of scores are between 85 and 130? Once again, these ones end up being on our thing, so sorry about that. So 85 is right here, up to 130. Okay. So now we just add the 3. So 34 and 34 would make 68, right? Because we already know that. And then 13. So 68 plus 13.5. Wow. I cannot apparently add with decimals, can I? 13.5 and 68. So we add that up, and that would give us 81.5%. Okay, now what percent of scores are less than 108? So now we have an issue, don't we? Okay, because 108 would probably be somewhere around here. Okay, that one's going to be tougher to figure out. So here's where we have to use our z-scores. Okay? And we have to find that percentile. So remember, for finding the z-score, it is our number minus the mean divided by the standard deviation. Okay, and then once we got the z-score, we go to our z-score table and we solve it with that. So, and that'll tell us the percent that is less than that. So ours is 108. Our mean was 100. Standard deviation was 15. So I type into a calculator 108 minus 100 divided by 15. Okay, I do that. That gives me a z-score of 0.53333333, which we round to the nearest hundredth, so it's 0.53. Okay, but that's not our answer. Okay, we need to have that percentage. So we need to look up a z-score table. So I should probably make a z-score table, huh? So let me get one. Alright, so here's our z-score table. Okay, remember our z-score was 0.53. So 0.53 if you really wanted to. So we take that 0.5. Okay, there's our row. Now we look at the O3 for the 3. Find out where they intersect. And that tells us our percent, 0.7019. So we'd round that to 70%. Okay, quite a bit of work to find that. Now we could have tried to estimate it by adding 0.15, 2.35, okay, plus 34, plus 13.5, plus, 108 would be almost halfway in between there, and so half of 34 would be 17. If we did that, you'd end up with 67, which is fairly close, but because we can do it exact, that's why we want to do it exact. Alright, now what if your IQ is 123? So now we're going to do the same process we just did, but this time with 123, which would be somewhere around there. So I go 123 minus 100 over 15. That's going to give us our answer. Okay. So 123 minus 100 is 23 divided by 15 gives us 1.533333. So we go back to our z-score table. We got 1.53. So I'm at the O3, but I'm going to go down to 1.5. Okay? Because those added together give me 1.53. So that's 9.9370, which if we round to the nearest hundredth, that's 94%. Because you'd round up there. So, our z-score 1.53. Our percentile was 94%. Sorry, I went a little ahead of myself on that one, didn't I? 94%. But that's not the answer of number 7. Number 7 wants to know greater than. That's the people that have an IQ less than that. So we'd go 100 minus 94, and we'd end up with 6%. Right? If you did the math. Alright? So what percent of people have an IQ score between 80 and 120? So once again, we're dealing with some issues here that aren't on there. So 80 would be about right here. 120 would be about right there. We want to know the difference in here. To find that, we find this percentile. That tells us to the left. We find this percentile, so 80 and then 120, and then we subtract the two. That'll eliminate this section, giving us the percentile in between. Okay? So we kind of have to do the same type of stuff. Let me clear some space. We find the z-score for each one, find the percentile, and then subtract them. Okay? So we'll do it for 80, and we'll do it for 120. So for 80, we go 80 minus 100 over 15 for our z-score. Okay, so we type that into our calculator, and it gives us negative 1.33. Okay, then we do it for 120. So 120 minus 100 divided by 15, which gives us positive 1.33. Okay, So they're both the same distance away, aren't they? 20 points away. So now we look at those up. Okay, so the first one, 1.33. Okay, so I go 1.3, so right here. And then we look at 0.3, so it'd be right there. Okay, so we'd get 0.9082, or we'd round up to 92%, or 91. 91%, right? Yeah. Then we do it for negative 1.33 when you have the negative, so we look it up the same way. There's the 0.03 that stands in for that, so we need negative 1.3. So negative 1.3 would be right here, and then we find where they intersect. So that's 0.0918, or 9%. Okay, so that one would be 9%. So then we just simply go 91 minus 9. And if you have to do the math, you do the math, and you'd end up with 82% people have their scores within that range. Okay? So now number 9 says, what is a z-score? Okay, well, a z-score, remember, when we're looking at it, it's where we sit on this bell curve. Okay? The number or intervals, the number related to the standard deviation from the mean. Okay, so how far away we are from the mean. That's probably the easiest way to say it. I'm not going to write that, but that's probably the easiest way to say it. How far away you are from the mean. That's what your z-score is, and it can be used to find the percentile. Now, what are the characteristics of a normal distribution? Okay, well, looking at this, we've got that symmetry on either side, right? We also have the median and the mean that are the same. We have the closer you are to the mean, the more you have. Okay, we have these percentiles, the 68, 95, 99.7 rule. We've got that. And it forms that bell curve, obviously. We have the standard deviations in line with those numbers. So that's pretty much the main stuff. Okay, and that one was for number 10. Alright, let's jump to the next questions. So, number 11. A researcher wants to know if a new soil additive helps plants grow more quickly. He grows 20 specimens in soil treated with the additive and 20 specimens in soil that has not been treated. Is this a survey, an experiment, or an observational study? So remember, a survey, you're asking questions. Experiment, you're trying to impact it by doing different things and being the change. Observational, you're just watching to see what the change is. So this one, pretty clear that it's an experiment. Why is it an experiment? Because you have 20 with, 20 without. So you're doing both to see what's going to happen. Okay. Number 12. To find out whether car accidents are more likely on rainy days, a researcher records weather conditions for 50 randomly selected accidents over the past year. So now this one's different than an experiment because he's not making them try to crash. He's not making people drive in the rain or on sunny days and seeing if they're crashing or not. He's just observing what has already happened and trying to gather the information. So that would be observational study. Okay, and the last one, a donut shop wants to know whether their customers prefer maple or chocolate donuts. They randomly select 50 customers and ask them which type of donut they prefer. So obviously that's pretty easy to see. That's going to be a survey because you're asking for input and information from those people. Okay, now 14 and 15, we're just identifying the population, the sample, and the parameter. Remember, population is your largest group, what you want to find out about. Okay, then the sample is the smaller group you're actually testing to see what happens, and the parameter is what you want to find out. Sometimes they'll call the parameter the statistic of interest, and it's called parameter when it's talking about the population, and it's called statistic of interest when you're talking about the sample group. Okay, that's kind of what you're looking at there. So, the student body officers wants. Well, apparently somebody did a typo. I didn't create this. It's not my fault. The student body officers want to know what activities students would like during homecoming week. They randomly select 5 homeroom classes and survey the students. So, population would be the high school students, right? They want to know what everybody. The parameter, what they want to do during homecoming. The sample would be those 5 homeroom classes. And if we talked about the statistic of interest, it would be what those 5 homeroom classes students say about what they want to do during homecoming. Okay, that would be the difference between the parameter and the statistic of interest. So number 15, a city council wants to know the average number of people living in residences in their city. They randomly select 10 neighborhoods in the city and go door to door in those neighborhoods asking residents how many people reside in their homes. Okay, so we want to know the average number of people living in homes, right? That's our parameter of interest. That's our statistic of interest, our parameter. The population would be the residents, right? The city, the people living in the city. And the sample are those 10 neighborhoods when they go door to door to those houses. Okay, the 10 neighborhoods they actually visit. That's our sample. All right? So now 16 says a poll asked 150 teenagers if they use social media. 114 said they did. What is the sample proportion, p hat, and the SEP? So remember, p hat is equal to our number over the total number. Okay, so 114 said they did in social media out of 150. Now we can leave it as a fraction, or we can turn it into a percent. Usually we like it more as percents and decimals. So 114 divided by 150 gives me 0.76, or 76%. Okay. Now the SEP, remember we find that the sample error of proportion, something like that. Okay. So that one's the square root of p hat times 1 minus p hat over n. So n would be 150. Okay. So I'll use this space down here. So it would be the square root of 0.76 times 1 minus 0.76 divided by 150. So you type that into your calculator just the way it is. Okay, square root of, then do a fraction, 0.76 times 1 minus 0.76 over 150. That gives us 0.034871. So if we round to the nearest hundredth, basically it would be 3%, 0.03, or we could say 3%. Okay, for number 16. Now, number 17 says the average height of 30 basketball players is 74 inches. What is, with a standard deviation of 3 inches, what is the SEM? Okay, that's the standard error of the mean. Okay, for this one, and I know there's a ton of formulas, isn't there? It's standard deviation over the square root of n. So n would be 30 basketball players. S would be 3 inches. So we just go 3 over square root of 30. Okay. We put that into our calculator, and we get 0.547723. So this is inches, so we don't turn it into a percent here. Okay. So, but we could round to the nearest hundredth, which we'd round up, and we'd say 0.55 is the SEM. Okay. That's standard error of the mean. So our mean is going to fall in, the population would fall in from the sample within this interval. It says 18, a new police chief reports that he has 20 fewer incident reports since he became chief. What questions might you have about his claim? Alright, I suppose main question is this police chief telling people not to send in incident reports? How many does 20 fewer mean? If you're getting, 10,000 incident reports, and now you're getting 980, okay, that's not going to feel like a big difference. So what's the total number of incident reports? I would want to know. I'd also want to know, are there any changes in reports? Are some reports that used to be incident reports now filed under something different? And so that could have an issue. There's a lot of different things. Plus, what's the size? Going along with this, what's the size of the police district? Is it a big one, small one? If it's a small town, 20 is a big deal. If it's not, 20 isn't. Okay, so those are kind of the main things that I'd be asking about and looking into when looking at this information. Okay. So now looking at 19, a statistical report claims a 95 confidence interval. What does this mean? So remember, looking at this, it has to do with the bell curve again, right? You've got your mean, and we've got 1 standard deviation, 2, and 3. Okay, a 95% confidence interval is basically saying if we go to 95%, which actually would be about right here, okay, what is the size going to be at 95%? 95% of our stuff is going to fall into what? Our confidence of this aspect is 95%, so we're confident that it will fit within here, 95% of it, okay, which is basically, it's actually 1.96, but we usually say, we typically round that up to 2. Though when we're using calculations to do it, when we actually figure the confidence interval, we really need to use the 1.96. But if we go back to this one, okay, we call 2 standard deviations 95%, just because of the number. And if we went to the z-score and went to 2.00, okay, 2 standard deviations away. Am I looking at this right? Yeah, it would, maybe not looking at that then. Okay, but it's basically 1.96, because if we go to 1.9, that's what I was doing. 1.96, that's what I was wanting to look at. So if I go to 1.9 and then 0.06, I knew this was going to show me something. That's 97.5%. Okay, that's why we can't do what I was thinking we could do. That 97.6 is going from this way. It's not going out from the mean. That's kind of, I guess, the major difference there when talking about them. But the idea here is that it's telling you that interval right here and that area with a problem. Okay? Alright, so let's take a look at these and see what we can do with these last, I think, 2 more problems, right? Alright, so you are a real estate agent who has been assigned by your supervisor to analyze home sales in your town for the last 6 months. Use the following table, which shows the sale price for several homes in hundreds of thousands of dollars. Note, some months have fewer values, obviously. So we want to calculate the mean, the standard deviation, and the SEM for your sample. Okay. If we assume that housing prices are normally distributed, calculate a 95% confidence interval for the mean. All right, so we got a lot going on here. Okay. Then apparently we're going to eliminate the 2 lowest priced home sales and reevaluate all of that. See what that looks like, and then decide what we want to talk about. Okay. So there's a lot to this question. A lot of thinking, but this is kind of how this stuff is used, so it's really important. Now, we're going to want to use our calculator here, and I understand that the problem is that you probably don't have a calculator at your house to use. So hopefully you're able to pop in, borrow the calculator in class here, and we can do it that way. So I'll probably use some screenshots to help remind us how we can figure this stuff out, okay? Alright, so I went in the calculator to do all this stuff. So remember, we want to enter this all into the all of it. I meant to make it like cover the whole thing. There we go. We want to enter all that into the calculator. So to do that, I've kind of taken some screenshots here with the calculators to explain it, okay, in case you've forgotten. So we start out, you want to make a new document. Okay, when it goes to it, you want to add lists and spreadsheet. Okay, now I've actually added a few other ones, and so just so you know, you also want to do data and statistics and a calculator for what we'll need. Okay, the way you get a new document, well, from a new document, the way you get a new page is if you press down Control, and like you don't have to hold it down, you just press Control and then you press Doc. That'll give you the plus page. Okay, then on the list and spreadsheet, type in a title. I just did house. Then you go in and you enter in every single piece of data. Okay, and then take it back up here to number 1. Then from there you hit menu, go down to statistics, stat calculations, and then up to one variable statistics. Click on that and you'll see this. Click down here, choose your list, then you hit OK, and then it gives you your list. You scroll down a bit, and the two pieces of information we're looking at is the mean here, X bar, which is 222,000.125, and the standard deviation, which would be 84.58. So you could just round that to 84.6. Okay, so that gives you two pieces of information, right? The mean, which was 22.125, okay, and then the standard deviation, which we rounded to 84.6. Okay. Now to find the SEM, okay, we take that standard deviation over the square root of the total number that we had, okay, which was 24 houses. Then I type that into my calculator, and I think I have it down here somewhere. There we go. So I type that in, and it kicks out 17.2689. So 17.2689. Okay. Now it wants us to calculate a 95% confidence interval. Okay. We may have to make another video to finish off this last one. So to do that, it's actually you take this SEM and you multiply it by the confidence z-score. Okay, and that's the plus or minus. So we take that 17.27, we'll say, and we're going to multiply it by, we go over here to the confidence, a 95 is 1.96. So we multiply that by 1.96, and that's going to give us that 95% confidence interval. And that gives us plus or minus 33.85. Good round. Okay. So what that tells us is that margin of error, okay, is 33.85. So anywhere, if we're talking about using this for a whole population, our mean is anywhere from this number plus or minus the 33.85. Okay, so if we take the 222.125 and subtract 33.85, that gives us 188.275. And then if we add it, okay, then that gives us 255.975. So 95% of our cells should be within those ranges. Okay. Now we're going to do the same thing for B. Okay, and I'm going to do that and just put down the numbers and then we'll answer C. But basically what you do is you take a look at those numbers. Dang it, there's a lot here I wanted to show you guys, other stuff. But you go back to here, and if you just delete those two lowest numbers, they'll actually give you the information you need. Now I'm trying to figure out where I put that last information. Here it is. So when we do that, we get our new mean and our new standard deviation. Then using the SEM, we figure out the same way we did for the first one, and we can find that interval. So if you pause this page, you can see mean, standard deviation, and all our information.